How does a generative AI model work? Well, let's start with a simple sequence of text. For example, I heard a dog bark loudly at a cat. Our challenge is to create a model that reflects the meaning of this text, not just the individual words, but the contextual relationships between them, enabling it to predict the next word in a sequence and generate natural language that makes sense. First, we tokenize the text, breaking it down into its constituent parts, or tokens. Then we assign an ID to each distinct token. And as we include more text, we add an ID for each new token we encounter. Next, to help us encode relationships between the tokens, we'll create a vector for each of them. In other words, a representation of the token that consists of multiple numeric elements. In this case, we'll keep things simple by using vectors with only 3 elements. You can think of these vectors as representing paths in 3-dimensional space, forward and back, left and right, and up and down. The vectors are initialized with random values, but then we feed the token vectors through the layers of a transformer. The vectors are transformed by embedding values that reflect the linguistic relationships between the tokens based on the contexts in which they're used. The details of the encoding process involve some complex math, but the key thing to understand is that a process called attention is used to examine each token in the context of the other tokens around it, and to determine which tokens most influence the current one. The result is a set of vectors with linguistic and semantic characteristics embedded in them, so we call them embeddings. The element values in our embeddings are based on how tokens are used together in sequences of natural language, so they reflect semantic relationships between the tokens. Tokens that are used in similar contexts tend to have similar meanings, so their direction through vector space tends to be similar. For example, the tokens for dog and puppy are likely to have vectors with similar directions. However, the token for skateboard will have a vector that's significantly different to dog and puppy, but maybe closer to something like car. And because the generated embeddings are contextual, there may be multiple embeddings for the same token, depending on how it's being used. For example, the bark of a dog is different from the bark of a tree. In reality, embedding vectors have many more than 3 dimensions, but the principle is the same. We can use a mathematical function called cosine similarity to measure how closely related, and therefore semantically similar, vectors are. Attention is also used to decode embeddings in order to generate new sequences of text. During the training process, the attention layers assign weights for each token based on the relative influence of the tokens preceding it. A neural network is then used to predict the next word in a sequence based on those weights. The predicted token is then added to the sequence so far, and the process is repeated for the next token. In this way, a trained model can take a sequence of words like "when my dog was A" and use the context of the words in that sequence to predict that the next most probable word is puppy rather than, say, cat or skateboard. A model trained on a sufficiently large data set and with thousands of dimensions in its embeddings can take a natural language input, which we call a prompt, and generate a completion that reflects the semantic relationships between the embeddings. Or put more simply, it can string a coherent sentence together.